Hello, good morning or good afternoon, depending on where you are following us. I like to give you a warm welcome to our webinar today, Automate Your Code Compliance by Using a Static Analysis Tool. My name is Andreas Schepanski. I'm the CEO and owner of QA Systems. With me is Jürgen Bechtloff, who's responsible for the technical support. I'm already need to apologize. We are both not English native speakers, but we will do our best that you can understand us. And fortunately, as we are not native speakers, we are not talking too fast, which is, I think, very positive for you. Okay, you are all unmuted. If you have questions, just put the questions in your question window. We will have time at the end to discuss some of them. If we get a lot of questions, we will definitely answer them all after the webinar. In case you have any problems, technical problems with the transmission, we will record the webinar anyhow and can send you a copy later on. Okay, so therefore, I think I'm going to start. I don't hear or read any complaints that you can't hear me, so therefore I assume everything is fine and we can immediately start. Therefore, I switch off my camera that you can really focus on the important things and don't need to see me or my colleague. Okay. So the theme is static analysis, and as you may have already heard from other vendors about that theme, I have a slightly different approach. I would like to go a step back and argue a little bit why we should do that. And the best route is always it's cost driven. Yeah, we have here data from the IBM Science Institute that shows us the cost to fix a bug is up to 100 times more expensive if the project is already in the maintenance phase, or even 4 to 5 times more expensive during the test compared to design and coding. Now, the majority of the defects are anyhow introduced at the coding stage. Yeah, and of course, you will catch defects throughout the whole software development lifecycle. But it's all is very important, and that's the shift left. And that means through the use of static code analysis and the execution of module tests, errors are found earlier and therefore much cheaper to fix. Yeah, so this is the real aim why we should invest in static code analysis and dynamic testing. Yeah. Now, if we look to quality features during coding time, what is it? Yeah, we have on the one side the process, and we have on the other side the source code. For the process, you have quality criteria like whether you have a version management or not, how is your configuration management done, what are your tests, how well is everything documented. Nowadays, you do a lot of with DevOps, and that's all things that will define the quality of your process, but none of them will define the quality of your source code. Therefore, for source code, you need to think about portability of your code, maintainability, reliability is of course a very important thing, and of course also testability, whether you can really test your code at all or not. Yeah. Now, for the process, there are a lot of solutions, all process-based, starting from ISO 9000, CMMI, SPICE. Also, the newer safety standards are mostly focusing on the process, and only parts of them are looking a little bit to the source code. Therefore, there is still a very big need for a programming standard. The programming standard decides the rules and guidelines to achieve your quality criteria like portability, maintainability, and so on. So this is one part of a coding standard. A second part, and that's for me the far more important part, is you should try to bypass the unreliable language elements of the standards. And all C or C++ standards have these unreliable language features. Yeah, so you should work in a safer subset of this bigger ISO or ANSI C++ standards. As examples, I think you all have seen a lot by yourself. The first example on the top left is if you put a 0 before your number, it's an octal number and not a decimal number anymore. Or a very common problem is if you put an assignment in an if statement. Yeah, that happens usually very often, and that's a typical mistake. What you don't do only once, you do it several times in your life. Yeah, and there are a lot of these issues what you need to look with your coding standard to avoid this. Yeah. Now, there are a lot of coding standards outside. We have the MISRA standards. There are different variations. We have CWE, CERT, AUTOSAR. There are, in the past, there have been a lot of own coding standards written by the companies itself. So nowadays, you have really quite a lot of coding standards what you could use. So what is important for a coding standard? What makes a good coding standard? Yeah, and also here, one of the biggest positive things about a coding standard is if the rule compliance can be largely automated. Yeah, it is not very helpful if you have a lot of rules what you need to manually look and correct it. Yeah, it's important that the coding standard is written in a way that tools can automate the enforcement. Yeah, it's also important because the language standards are developing further. That you have a coding standard which goes with the standards. That means there must be a further development of the coding standards. In all the cases, there will always be exceptions that you have a rule what you would like to not follow in that certain case. Therefore, you need a procedure for managing rule deviations. Yeah, I come to that a bit later. Yeah. Also, it should help you to just get fewer errors for further testing. So it should really help you to avoid mistakes during the coding phase. And as said, this all result in a better maintainability and manageability of your code. Yeah, and this is consistently a good quality source code. So it's a good programming style. But as everything, we don't have only pros. We have also contras of a coding standard. I announce it as dangers of a programming standard. First of all, what we hear from time to time is the lack of acceptance by developers. Yeah, if you have developers who are ignoring your coding standards, then you are anyhow in trouble. But this is, to our experience, just the way how you roll out a new coding standards. In the past, and unfortunately that's not nowadays a very important issue, is the lack of the knowledge in creating a programming standard. As I said, in the past, a lot of companies developed their own coding standards. Nowadays, it's more that you use an existing coding standard, and therefore that's not a big thing. Even if you have programmers which accept the coding standard, it's always insufficient with your compliance. A coding standard has between 100 and 200 rules, and you cannot ask every developer to have them all in their mind all the time. So doing mistakes and not fulfilling coding standard rules is just a normal thing. Yeah. The verification through a manual code review is possible. Yeah, but this is just far too expensive. Yeah. As a result, what we can see is a program standard that is not checked, that loses its significance. That's also a very important thing. You need to check a coding standard. Otherwise, yeah, it will not fulfilled. So why are we then not using code inspections? Yeah, we have lots of very positive comments about coding inspections. Yeah, again, an example from IBM reports that it took only 3.5 hours for a code inspection to find a major defect, and finding the same defect through the testing would take more than 15 to 25 hours. Another example from Germany, an airlines division of Softlab, they had a project where they found 37 major defects with reviews. Yeah, the average for finding the defects was just an hour per defect. Yeah, finding the same errors in a testing phase would have taken them 3 to 6 times more time than in the code reviews. Yeah, I have another graphical example from Alcatel, now called Thales. They compared projects with the effort, with limited effort for code inspections, with similar projects where they spent a bit more effort for code inspections, but then saved a lot of time during the integration and system tests. Now, you can do that, or you can think you do it even better and say, okay, in that case, I double my code inspections work again, and then I don't need to test at all. But that's also not possible, because you don't find all kind of errors with code inspections. Yeah, for example, timing errors are very hard to find with code inspections. Yeah, so but the class you find with code inspections are found much faster than you would find the same defect with integration or system tests. Now, also here, why are code inspections often cut or cancelled or not even done at all? Yeah, and there are also a lot of different arguments against it. First of all, and that's for me the main argument, programmers and testers do not like code inspections. It's kind of a boring work. Yeah, it's reading code is a bit, yeah, not very makes you not very happy. Code inspections could also mean confrontation and emotions, because at the end of the day is what you are doing is reading code of someone else and telling him that he made some mistakes here. Yeah, so this is also a bit tricky. Yeah. Effective code inspections are also quite time consuming and cumbersome. We have a 2-day seminar about how to do code inspections. So although they are very efficient, there are, as I said, also quite a lot arguments against it. And a very common decision is if the calculated time in the project is not sufficient to perform the code inspections, they will be cut. Yeah, and we see that as a wrong decision. Code inspections should not be cut. The right solution is the automation of the code inspection process. Yeah, and that's what we propose. First of all, you should define a coding standard based on MISRA CERT CWE. You should do that with an audit with your developers, defining what is really needed in that project. Yeah, sometimes you don't need portability because this will not be ported anyhow. Yeah, so therefore make an audit and define a subset of different rule sets. Yeah, from these common coding standards. As a second step, and that's the important thing, automate the verification of the coding standard with a tool. Yeah, and we of course propose here using our tool QA-MISRA. And very important is you should do that directly at the developer's desk. If you do it centrally in your DevOps, this could always seen from a developer like a control mechanism of his work. So the better approach is definitely let the developer work with the tool and help him to supply quality code which is coding standard aligned. Yeah. As the next step is selection procedure via metrics for anomalies for code inspections. You can use software metrics calculated by a static analysis tools to define the areas what you think it's worth to look into a code inspection. I come to that point again later. Yeah. You should not forget to do the module test and the code coverage. Of course, also we propose with Cantata with our tool. But at the end, and that's also a important thing, is you should use a sound analyzer such as a S3. Now, what do I mean with sound analyzer? There are different static code analysis methods, and the categories are depending on the depth of the analysis. Yeah, we have syntax-based analysis methods. They are very good for coding guidelines checking, like QA-MISRA. Yeah, these guidelines are mostly syntax-based. Yeah. There is also a question of how many false positives or how many false negatives you have when you use such code inspection or static code analysis tools. Yeah. If you have too much false positives, then the effort you need to spend to figure out the real ones are quite high. So it's not very sufficient. On the other side, if you have too much false negatives, you miss a lot of errors. Yeah, you miss a lot of problems, and that's also not very positive. Yeah, so the second part or style of tools are then tools which are also semantic based. These are typical bug finders, bug hunters like Coverity, Clockwork, QAC, and so on. Thing is, false positives are possible, yeah, but false negatives are also possible. I would like to show that with the graph here. So these small dots are no further coronavirus creations. These should be the bug, and you find bugs with the blue by using a bug finder. Now, we have seen approaches because as you don't find all bugs and as all bug finders find different things, that companies start to use a second bug finder to find something else, and a third or a fourth bug finder. But that's, to our opinion, the wrong approach. Yeah, because with a typical bug finder, you will never be sure that you catch all bugs. And therefore, it's important, and that's what we propose, to use a sound analyzer. It's called sound because it's based on an abstract interpretation of the source code, and therefore there are false positives still possible, yeah, but they are quite rare. But the very more important thing is there are no false negatives anymore. So you can be 100% sure that if a sound analyzer like a Stray, run over your code that you have not missed any runtime error. And that's really proven. And therefore, instead of using 2 or 3 bug finders, do it right from the beginning. Use an easy tool for the syntax-based code, which checks your coding standard, and then use a sound analyzer to catch all the bugs. Now, how should that look like for the process? Therefore, we propose to use QA-MISRA and Cantata directly at the developer's desk. Yeah. The requirement here is that the analysis time should be very fast. Yeah, and that's, for example, with all the other bug finders, that's a problem because they take much longer. Yeah. So and if you have to ask your developer to wait a couple of minutes till his source code is analyzed, that makes him not really happy. So he would like to go further and start immediately looking to the results. And therefore, it's important to have a very fast turnaround, and that's possible with a pure syntax checker like QA-MISRA. And then on the other side, to catch all runtime problems, you use the sound analyzer in your build process, yeah, because they usually take a little bit longer to analyze, but that's not a big problem. If you establish that in your DevOps or in your nightly build, you will get them all on the next day. So this is the proposal how to use the tool in your process. Now, I would like to come back with how the software metrics can help you. Yeah, and the software metrics can help you definitely to identify complex functions. There are a lot of different metrics out there, from cyclomatic complexity till the level of nesting functions and so on. They all can help you identify the complex parts of your software, and therefore this could be then used for the manual code inspections. Yeah, metrics can also be used to estimate the effort which is required for dynamic testing. The number of rule violations is also a metrics, and this is a good indicator. Also, if you have areas in your code where you have a lot of deviations, a lot of MISRA violations, then it's also worth to go over the code with a manual code inspection. Yeah. One thing with metrics is quite important. It's not the single number that brings the value. The value is in the history. So therefore, we propose to calculate the metrics and store them, yeah, with every single version. And over the time, you can build a system where you can rely on the differences. For example, if you have had some metrics about testability, and you had a project in the past with an average testability, let's say a number of 10, and it took you 2 months, man months of effort to run the tests and write the tests. And then you compare that with an actual project where you also calculated 2 months of effort, but the testability metrics are showing a testability which is maybe 3 times worse than in the old project. And then you have a very good indication already before you start with testing that the time you proposed for the test is not sufficient. Yeah, that's how you need to work with the metrics. So it's not the single number what brings the value, it's the historical data. And therefore, my approach would always be start with storing the metric results for every single version. A high number of deviations could also be an indication of, for example, very hardware optimized functions or hand optimized functions. You have that in very close runtime or memory optimized in very driver software, and this, for example, they don't need to be very portable. Yeah. It's also if you see unspecified, undefined, and implementation dependent language behavior. Yeah, and at least you can also figure out unwillingness from individual staff members to comply with the coding standard rules. Yeah, and then you need to talk to them with in a personal manner. So what is important if you look for coding standard checkers? What kind of features are helpful? Yeah, first of all, it should support more than one coding standard. Yeah, it should support all a variety of different coding standards, what are common used in the market. Yeah, it should also have a compliance matrix for each supported rule set that gives you the ability to check very precisely what is really checked through a coding standard tool and what needs to be done manually. Yeah. As I said before, it's very helpful if you have a very fast analysis engine. Yeah, a developer don't want to wait a couple of minutes till he get the results. Yeah, a couple of seconds. That's what he's aiming for. Yeah. Then of course the test accuracy. Identify as many definite violations as possible. Yeah, but look that you don't produce too much false negatives. Yeah, or false positives. Yeah, and yeah, the aim therefore is generate the smallest possible number of incorrect diagnostics. That makes it really efficient. Yeah. What else? As I said, a static analyzer, a static analyzer should definitely help you to calculate the software metrics. Yeah, that you can then store and work on a bit later. Yeah. Also, quite important is the reporting. A fundamental element of the MISRA compliance is the investigation of all reported rule violations. Yeah, and you have always different classifications, whether it's a correct diagnostic or you need to look have a deeper look into that, or it's a false diagnosis of the violation, and you should be able to store that in the product and comment it, and therefore you can then afterwards run reports and show exactly where are the violations. Yeah, at the end, quite important is of course an integration with your development platforms and processes that makes the usage also fast and easy for the developer. And last but not least, and that's of course quite important, the rule set needs to be customizable. Yeah, because sometimes if you had, for example, auto-generated code, you can run with a different rule set compared to code what is manually written. Yeah, so these are some ideas of what you should look for the MISRA checker. So as summary, an early error detection reduces costs. Yeah, that's definitely nothing new, but is still very valid. A programming standard helps you to avoid errors, but should definitely be checked automatically. Yeah, code reviews are efficient, but should really focus on logic. Yeah, not on formalism. Yeah, the automation of the code compliance needs to be done by a tool. Yeah, you need tool support for it, and use the analysis results for the definition for further test activities. Yeah, good. I come more or less close to the end of the theoretical part. I would give you a short overview about QA systems, what we are and what we do. We have two main areas where we supply products and services around, and one is of course the QA-MISRA, the static analysis tool, and the Cantata with the automated unit and integration testing for C and C++. That's supported by our academy, where we offer seminars, webinars like this one, or training courses. Yeah. Our history is quite long. I founded the company 25 years ago, and I'm now really in the business for static analysis since the beginning. This was the aim of the company, providing static analysis solutions. And since 2012, we added the dynamic testing with the purchase of Cantata from another company, and therefore the rest is just further expansion and development. Yeah, we are quite internationally based. Meanwhile, our headquarters is here in Stuttgart, Germany, but we are quite focused in Europe, in UK, France, and Italy. But we also have a subsidiary in the US, in Boston, and meanwhile also in Da Nang in Vietnam to serve the Asian market. Yeah. We have, of course, a lot of customers. The markets are quite various, from automotive to medical to railway, military and defense, and so on. Yeah, therefore, I would like to close the theoretical part now and would like to hand over to my colleague, Jürgen Bechtloff, who will make who will show you the tool itself in a short overview, and after that we will be able for questions. Jürgen, I will transfer to you. I think you are ready.
Yes. Hopefully you can see now my screen. So this is the graphical user interface of QA-MISRA. That's what I want to show you now. So the first thing, we have a common information part. Here we have the possibility to give the project a name and a short description about it. The complete project configuration can be exported or imported on another location. So that's why it's important that we have the possibility to specify a root, a project-based directory, so that the rest of the configuration can be stored with relative path information. So like every static analyzer, we need some configuration. I want to focus today on the rule configuration, but it's important to notice it's also necessary to do a setup of the preprocessor settings, include path information, things like that. Here is it possible, for example, to import a compilation database, a JSON file that can be generated by, for example, CMake or Ninja or other make systems. So let's focus on the rule set now. So I want to show you, I have here an open source project like you have seen in the information. It's an open source project, a GNU project. It was not developed with MISRA in mind, but I do a MISRA checking for this project, and it's a version of the GNU project that have mixed code. So we have C and C++ source code in the project, and doing an analysis for MISRA compliance for this project, we get over 17,000 rule violations. So it makes not really sense to do a full MISRA check on it, but I start the presentation now with the full MISRA checks to see how the configuration looks like, how it can be modified, and also how it's possible also to handle a big number of rule violations by using some filter functions, and it makes it possible for you to focus on the things you are interested in. So let's start with the MISRA configuration itself, for example, here. We have here the MISRA C 2012 standard. We have the amendments 1 and 2. And for example, we can see some of the rules can be configured, like this rule. And we see for each rule, we have checks that are necessary to check the compliance with this rule. If we select one of these checks, we get here the information that the check itself is maybe not only assigned to one rule. So in this case, we see this check is also used, for example, to check the AUTOSAR compliance, or CERT C, CERT C++ compliance, or other standards. So it's possible that we have a check that is assigned to more than one rule. And yeah, that's important to know. And it's possible that you do also a configuration that use a combination, for example, of MISRA C and CERT C rules. So another possibility is that we do here a recategorization of the single rules. That's also something that is mentioned in the MISRA compliance documentation, like the deviation procedure. Andreas already mentioned it, and I will also have a bit more information about it a bit later. We have here the possibility to, for example, define a subset that we select only the mandatory MISRA rules or things like that. Like mentioned, it's important that we have a fast analysis. So we can see here for the full MISRA compliance check, there was 13 seconds be needed to do the full MISRA compliance checks. And we get all the results in the overview. In the overview, we have different perspectives. So the first perspective is the rule violations view. So it's like the rule configuration. We have the grouping here. For example, I mentioned it as basic check. So this is the unspecified, undefined behavior, for example. If we do here and double click, we get the first filter. So we see here only the unspecified behavior diagnostics that were be found in this project. So this is one possibility. If we select a single violation, check that is failed, we have also the possibility to see to which rules this check is assigned. We have also the possibility to do some other things like the deviation procedure. The deviation, the commenting of an alarm can be done on the server in QA-MISRA directly, or it can be also be added as a command into the source code if required. So the next thing is we have also the possibility to get the overview related to the checks that are failed itself. So again, a double click will open here and filter, and we see only the checks that are failed here, and we see all the files that have violations where this check was failing. The next thing, we have a perspective that's more the programmer preferred view. We have here the possibility to select a single translation unit, and also in this translation unit, we can specify a single function. Then we get here again a filter, and only the rule violations for this function will be listed here. So for the presentation, the exact presentation of the diagnostics, we will see it a bit later when I have changed the configuration and we have a deeper look on a smaller subset of rules that make more sense to check in this open source project. The next few possibility is if we have done some classification of some findings, we have also here the possibility to specify what we are interested in. For example, by a right click, we can then specify, we want to see all the findings, or we want to see only the undocumented findings, so that we can also do an commenting and classification of this not already documented findings. So like mentioned, metrics are very important. So it's also important to know that the tool calculated. We have here the project metrics. A simple project metric is, for example, the number of files or the number of functions that are implemented in this project. We have file metrics, so per translation unit, how many functions or methods are implemented in this translation unit or in this function. If we have a look at the function matrix, there are some things like the cyclomatic complexity or the number of parameters for a function, etc. So all these metrics can be calculated or are calculated. We can define thresholds and check the compliance with these thresholds. That mean we generate an alarm if the threshold is violated. And the next thing we have here, so in the static analysis, we get also the control flow information. In the control flow information, we can, for example, do also in filtering. If I delete a filter, I see all the callees and the callers that are in the project, and I have also here again the possibility to use a filter that I see, for example, only the function gen moves. So I see which functions are called by gen moves, and also I see the functions that are calling gen moves. If I select one of these lines, I have also the possibility to see the result in the editor. So I see exactly the location where the function is called. And I have also the possibility to specify or have a deeper look on the call graph. So that's what I want to do now. So I start here the call graph view. In the call graph view, I have selected the function. The function is the function in the middle. It's the genMove function. I get here the number of alarms. A is the short form for alarms. I see the caller of the genMove, and I see also the called functions. I have also the possibility to get a deeper or more information about the call tree itself. So I can specify the visible depth. So it's, yeah, also here in yellow, if a function has no alarms, it's a yellow bubble. The selected function is the blue bubble. A function with some alarms is the red bubble. I have here also the possibility to specify another function and say, okay, this should be the function I'm interested in, so the view will be changed. I have also the possibility to see, to specify and filter that I only want to see the violations that are related to this function, and also some other possibilities. I want to go back to the overview now, and like seen here, it can be much information, so maybe it makes also sense that we do an additional filtering. So the overview tabs will be affected by a filter that I can set. So for example, I can specify that I'm only interested in, for example, a single module like this front end, and can store this filter. Then the overview will only list the violations of this module. So I want to go back to the configuration now. And like mentioned, we have here many rule violations, and the full MISRA compliance check make not really sense for this GNU chess. So I have the possibility to also disable the full MISRA compliance checks. It can be easily be done by disable configuration. We can add a new one. For example, we add now a configuration for the CWE. We can specify the folders that should be excluded or included. So for example, I do not want to check the compiler headers for compliance. So I select the folder where are the compiler-specific headers are located and do an exclude, and I have also the possibility to specify the module or the complete project. In this case, it's the source root folder where all the sources are located in subfolders I want to check. And now I have a new configuration. It's called, oops, sorry. I have to delete new configuration in the name. I can specify which rules should be activated for this configuration group. So I want to disable the basic configuration because I have already a group that is doing these checks. And I have here the possibility to specify that I want to enable all CWE checks for the project. And also, like mentioned, it's possible to import or export some configurations. So I have prepared some MISRA subsets I want to import now. So I want to import only the rule configuration. I specify the subset configuration. There's a possibility if I have some configuration files that include more than the rules to specify what part of the configuration I want to import. So in this case, I only want to import the rules configuration. Now we see we have here a subset C for the C part in the project and a MISRA C++ subset rule for the C++. So we have now a complete new configuration. It's doing only a partial check of the MISRA rule set. And we start analysis now. When we start the analysis, we get here some information in the output view. In the output view, we get all the information about the configuration of the tool, the single steps by the analysis. So we have a pre-processing, we have some checks that are be done on the original source file. We have some checks that are be done in the pre-processed source. So yeah, you see after the change of the configuration and do a reanalyze, the results are finished after 12 seconds. I have here all the information about the configuration that is be used for this project and the single steps like yeah, the original source pathing or something like that. So it's easy to navigate to the section I'm interested in. I have also the possibility to specify what I want to see in this output view. Do I want to see everything, all messages? Do I want to see only errors and alarms? Or as other filter, we have the possibility to specify error alarms and info information. We have also the possibility to do an step-by-step from error to error, for example, or from alarm to alarm or to the last alarm. That's what I want to use here. You get here the presentation of the check that is failing. That's the called alarm. We have here the original source file location where this alarm is related to, and we have also here highlighted of the section in the source file that is the trigger for this alarm. So if we do a double click here, the editor view will be opened. We see on the right side original source file and on the left side a preprocessed source file. We have here the possibility to go in deep, for example, in this findings view. Here we see now the different classifications. I have here prepared some of these classifications. Each of these classification, like mentioned, can be done directly in QA-MISRA. So it's stored in the database. of the project, or you can edit it to the original source file. So information how this should be done is also be available in the help. So the tool offers also a help PDF file that can be opened in this view. And you get all the information how you do the MISRA compliance, the rule deviations, and also some other informations about the rule or the project configuration itself. So many information also about the rules and about the checks are available in this help system. So again, we can go back to the overview, for example, and specify a single group, for example, again, this unspecified behavior. So we have the filtering for this rule. We get here all the violations. And another thing is we can delete this filter simply. We can add, for example, a filter for a single file. When I'm interested, for example, only for the command file, I have the possibility to specify it here. Again, if I do a click on the alarm, the editor view is opened. I see the original source file and the preprocessed file. And I have also the possibility to use here, for example, a search function. And in this case, I want to search for a macro. If I click on this additional filter, I see only the rule violations for this single file. And in this case, we see exactly how this macro set is expanded and how does it looks like in a preprocessed file. And we get here exactly the location, the part of the expanded macro that is triggering this rule violation. So another example for a diagnostic is when we change the filter here, for example, and select the file attack. We have here also an interesting rule violation. We have here the problem that the declaration and the definition are a bit different. So when we select the first part, we get the source code location. We see here the definition of the function attack2, and we see the parameters have a name. If I select now the declaration, I get a location in the included header file, and I see the prototype of this function. It specify only the type, not the name of the parameters. So it's a bad thing, because it's for the compiler not possible to do some further checks, and also the static analyzer or the programmer may be confused in this area. The next thing I want to show you is there's also the possibility to search in the project for specific things, for example, for function names, for variable name, or for macro name. So let's, for example, look for a macro. It's called green attack. If we search for this green attack, we get here a list, and we see exactly where the macro is defined, and also where the macro is used. So it can easily be used to navigate and get more information about the different things. So at the end of my presentation of the graphical user interface, I want to show you the reporting. So I think this is one of the most important things, that you have the possibility to generate reports that including all the information you're interested in. So you have the possibility to specify your own reports, in the meaning of you can specify which information should be included in this report. So everything we have seen in the output view, all the informations are available to do here some report configurations. So I have here set up a thing or a report like the rule compliance, give an overview which rules are violated and how often. A classification report, it's the deviation report that lists all the rule violations you have already classified and commented. We have also the possibility to generate, for example, a report that include only the used configuration of the project, a single report that only include, for example, the findings, and a single report that include only the metrics, but you can also do some combinations in the way you like. So if you have the configuration, you can import or export it in other projects, for example. The next thing is you have the possibility to specify the location. Oops, sorry. The location and the format of the report. So the report can, for example, be generated as text file, HTML, or CSV file that can be, for example, be opened in Excel. So I have here a set of reports that are already generated after the analysis of the project. And I want to show you shortly 2 or 3 reports. So maybe most important for you will be maybe the findings report. We can, for example, do a double click here, and now Excel will be opened. And in this report, we have no information about the used configuration, only the name of the report configuration. And now we have here all the rule violations be listed. We get the information about the category, the check name. We get the location in the preprocessed file or in the original file, or both. And we get also information about the message text. So the relation to the mapped rule. And also, if we have done some classification, we get the classification and comment we have added to this alarm. Another thing that's maybe the thing I want to show you now is this classification report, for example, HTML report. So there's also an agenda, so we can easily navigate to the section we are interested in, for example, directly to the classifications. So we get here all the information about the alarms, the category, the location again, and the classification and the commands. And in this report, only the commented classified findings are listed. So yeah, thank you very much for the interest. So I will close now the presentation of the graphical user interface of QA-MISRA, and we can start with question and answers.
Yes, we are already a bit behind the schedule, so I would propose that we answer most of the questions afterwards by mail. There was one question whether there is an eval license available, and I can say yes, there is. Just go on our website and submit an eval request. And another question was about the license models, and I can announce that we offer floating licenses for QA-MISRA, which gives you the most flexibility in the usage. I would propose all the others. As I said, will receive their answers by email, and therefore I would like to thank you all for your time and your interest. And if you have further comments, we are happy to get your response about that webinar. Thank you, and I wish you a good day, good afternoon, good morning, or as I said, depending on where you joined the webinar. Okay, thank you all together. Goodbye.
Thank you. Goodbye.